Today I'm going to solve this system using the method elimination, which is also called the addition and subtraction method in some textbooks. Some people refer to it as elimination, some addition subtraction. But either way, what our whole goal with solving a system using this method is to eliminate a variable. Whether it's using addition or subtraction, it's kind of up to you. I don't necessarily like the terminology using the addition method because then everything is centered around making an addition problem, or the subtraction method because then you're centered around using subtraction. I don't like to be locked in that box. I'd rather just solve this whatever logical way that I could solve this using elimination of variables. So I'm not substituting, I'm going to eliminate variables. So we're trying to eliminate a variable. So what we were looking for here is either same coefficients, like +5, +5, or opposite coefficients, so +5, -5. If either of those two things occur, then we're in pretty good shape to either add or subtract. So let's just check out this problem. Let's see what we're working with here. So in the first variable, x, here I have a -1 and a +3. Opposite signs, yeah, one's negative, one's positive, but not the same coefficient. So that doesn't mean that we can't use that, but for right now, let's go to the y's now. Let's check out the y's. Let's see what we're working with here. So here we have a 2y and a -2y. Boom, there it is. +2, -2. They are opposite signs. They're both 2's, one's positive, one's negative. So in this scenario, where we have opposite signs, meaning positive, negative, same coefficient, we want to use the addition method. So we want to add the columns together. So here's how this is going to look. I am going to add the variables together, or the columns together. So I'm going to do -1 plus 3 for the x's. So -1 plus 3. -1 plus 3 is a +2x. It's just adding, subtracting numbers. Here for the y's, this is our whole goal. +2y plus a -2y. 2 plus -2 is 0. 0. It's gone. I've eliminated. So if you're ever in a situation where you're like, I don't know if this eliminates, here's what you do. Just try both. Try subtracting, see if any of the variables eliminate. Try adding, see if any of the variables eliminate. If they don't, then you got to do something. But here I did addition, and my y's canceled out. 2y plus -2y is 0. Those are gone, out of the picture. And then we do -3 plus -5. That's -8. 3 plus -5. 3 plus 5 is 8. Both are negative, so it stays negative, -8. And now we just have a one-step equation. So I'm going to solve for x by dividing by 2. X equals -8 divided by 2 is -4. So we have x, and we're looking for an xy, because remember, when we're solving a system, we're looking for that point where these two lines would cross paths. Sometimes there could be more than one point where they cross paths, or sometimes there might not be any point. But right now we have an x value, so now we have to check out what the y value is. So here's where you got to go back, though, and if you are someone who likes that visual, like, oh, I did it, 2y minus 2y, 0, that cancels. You do want to make sure you erase that or go back and just know, like, all right, it's not actually out of the picture because now we have to figure out what y is equal to. So I have to take x, and you have the freedom here to either go top shelf or bottom shelf, either or. I usually just try to do the easiest looking one, and both of these kind of propose their, give us a little bit of a challenge either way. I'm going to do the bottom. And I will talk about the top on a mistake that I know people will make if I assign this problem. There's a mistake there that I'm people will make, so I'm going to talk about that. But let's go ahead, substitute into the bottom. So 3 times -4. So what I'm doing right now is I'm replacing my x value with -4 in this equation. And then we just solve for y. 3 times -4 is -12, minus 2y equals -5. And then I'm going to add 12 over. So I get -2y. There's a mistake right there that could be made. That's -2y, so you got to bring that down as -2y. Equals 12 minus 5 is 7. This is looking kind of weird. I'm a little worried I made a mistake. Let's just double check. That's kind of a weird answer. So it's good that I'm checking this. Let's see. Why does I keep doing that? So I eliminated the y's. -1 plus 3 is +2. -3 plus -5 is -8. Divide by 2. X equals -4. Substitute it back in. 3 times -4 is -12. Minus 2y equals -5. -12. Add 12. 12 minus 5 is 7. -2. Let's check it out. And I could even substitute back into the original equations to check out. So we might as well, you know, since I'm not liking this answer, let's just plug them back in real quick. So I'm going to have 3 times -4. Let's do the top. So while I'm doing this, I'm going to mention a mistake that I would see here. So here I have x equals -4. I'm substituting into the top. It's -x, so it needs to be rewritten like this. And this is why I didn't choose the first one, just because I was almost sure that someone would make this mistake. And then we have plus 2, and you know what? Let's just solve this one for y. So this is going to be +4 plus 2y equals -3, -4, -4, 2y equals -7, divided by 2, y equals -7/2. So I was going to go the route of doing like the whole check, plug in x, plug in y, but you know what? Since I was talking about that possible mistake that I'd see, negative of the -x, since our x was -4, it should be negative times -4, which is a +4. So I got the same answer, so I'm good. So my ordered pair is going to be -4, -7/2. That fraction kind of freaked me out. I was not expecting a fraction on this problem. I picked it. Works out that way sometimes. So I used elimination. I eliminated the y's. And if you're wondering, like, why can't you eliminate the x's? No one says you can't. You could have eliminated the x's. That would have created more work for yourself, though, because you would have had to made these coefficients the same. So this was a +3, so this would have been a -3. So you'd have to multiply the whole first equation by 3. Not like it's wrong or anything, but you just create more work for yourself. So this was nice that it worked out where those are opposite coefficients. So then I could just eliminate using addition. So good problem there. Wasn't expecting the fraction.